So we can start the webinar now.
Okay, so I think we have around quite substantial amount of participants now. So good evening, everyone. Myself, Naved, I'm the moderator for today's session on the reliability of optimization in cloud and fog environments using machine learning techniques. I welcome you all to this, this webinar, this is the third webinar in the series which we are having. And, we already, sorry for the delay because we had some technical glitches. So we go ahead and start this webinar. So what I will do is I'll first call upon Dr. Nirmal Das, Chairman, West Bengal State Center, to give his welcome address. Dr. Nirmal Das.
Thank you, Naved. Am I audible?
Yes, sir, you are audible.
Okay. Thank you, Naved and audience. A very, very good evening to you all. Dr. Hemant Thackeray, our President, Institute of Engineers, Engineer, Dr. G. Ranganathan, Chairman of CATE, Engineer Amit Kumar Das, Chairman of Computer Engineering Division Board, Dr. Shoibal Sarkar, Chairman of Computer Engineering Division Subcommittee, West Bengal State Center, Engineer Pranab Kumar Dev, Convener of the Division, Dr. Raju Basak, Honorary Secretary of the State Center, today's eminent speaker, Dr. Debasrit Das, Associate Professor, School of Computer Science and Engineering, Vellore, past and present council members of the institutions, and distinguished corporate members, ladies and gentlemen. It is indeed my great pleasure and honor to be speaking here today in the webinar on reliability optimization in cloud and fog environments using machine learning techniques, organized by the Computer Engineering Division of West Bengal State Center, the Institution of Engineers India. Being the chairman of West Bengal State Center, II, it is my proud privilege to address the gathering of eminent engineers and technologists. On this occasion, let me extend a warm welcome to you all, and especially to our panel speaker, corporate members, distinguished guests, the staffs of IEI, and my dear students and other dignitaries. The digital age has experienced a rise in the daily utilize of intelligent devices and computers by organizations and individuals. Electronic devices are used to generate data through applications and sensors. However, certain big data generated by the sensors cannot be transferred to and processed by the cloud. Moreover, faster processing is required by several Internet of Things IoT applications. But current cloud capability will be unable to process such applications. This problem is solved using fog computing paradigm, in which the processing power of devices close to a user. Fog computing as a complementing technology for cloud answers the issues of latency and connectivity in the cloud. A major concept in fog network is its ability to learn and adapt a changing environment. This ability of the fog devices to self-learn and improve itself is the core of machine learning. Hence, machine learning algorithms occupy central place in visualizing robust and effective fog network. In recent years, an increasing intent has been observed in adopting machine learning to enhance fog computing applications and provide fog services like efficient resource management, security, mitigation latency, and energy consumptions, and traffic modeling. The machine learning applications for fog computing become strong end user and high layer services to gain profound analytics and more smart responses for needed tasks. Today, we have a very learned speaker on the theme. Let us explore and educate ourselves on a comprehensive review to underline the latest improvements in machine learning techniques that are associated with the aspects of fog computing, management of resources, accuracy, and security including the role of machine learning in edge computing. I hope you'll enjoy today's session. Thank you once again.
Thank you, sir, for your excellent welcome address and enlightening us on the topic for the day. We all believe that we'll all be enriched with a lot of information from the eminent learned speaker who is here, who is present with us today. With this, I would like to call upon Mr. Amit Kumar Das, Chairman, Computer Engineering Division Board, to address the gathering today. Mr. Amit Kumar Das. So, Mr. Amit Kumar Das is here.
I think he's not present due to his business, other business.
So we have the president of Institute of Engineers, Dr. H.O. Thackeray. I think he's also not there. He's not there, as well as Mr. Vice President, Mr. Sandeep Kumar Dev.
No, he's not there.
And Dr. Raja Ranganath, Chairman, not Committee there. For Advancement, he's not there. No. With this way, I go upon to call upon Dr. Shahbaz Sarkar. I think he is also not available today, Mr. Sir. Dr. Shahbaz Sarkar.
Pranab Dev, has he joined?
I don't think so, sir, because I'm not seeing Shahbaz Sarkar, sir, out there. So, I would not like to waste one more time. So today's, speaker for today's webinar, reliability optimization in cloud and fog environments using machine learning techniques. We have a very learned speaker, Dr. Debashri Das, Assistant Professor, Senior Grade 1, School of Computer Science and Engineering, VIT Vellore. So just a few insight into it, with the advancement of the smart cities, which has been which initiated by the government of India, and the amount of sensors and IoT deployment across major cities. This has really brought about great change in the way we do things. And as very well said by the chairman, Dr. Nirmal Das, that the reliability factor, the optimization, the quality of service which is supposed to be given by the sensors is become a major challenge. So with this, I think I would request now Dr. Debashri Das to take us a deep dive into this session, a very informative session, and enrich us on this topic. So it's over to Dr. Debashri Das, sir.
Yeah, a very good evening to one and all. I am indeed grateful to the chairman and all the panelists presiding over the session, and thankful to the participants. I am Dr. Debashri Das, working as Assistant Professor, Senior Grade 1 in the Department of Computer Science and Engineering at VIT Vellore. My research area is actually distributed systems, and the reliability is one of the parameters that affect the type of service that we expect from the distributed kind of environment. So today's topic will be focusing on the this QoS parameters. What are the QoS parameters? What is the concept of cloud and fog? And then slowly we move into the machine learning concept. Now, why at all the cloud and fog computing came? The concept of cloud, it came in 2006, right? The first the CEO of Google, Dr. Eric, he proposed it in a conference, this concept of cloud. And slowly in 2016, the concept of fog computing came. Now, why fog computing and cloud, why they exist? Earlier, the concept was limited to only parallel computing, and then the distributed computing one form came, that is called grid computing. Later on, people slowly migrated to cloud and fog, and now the current, the emerging area is on fog computing. The basic reason behind this is with the development of the Internet of Humans, we can say. Earlier, there were no mobile phones, there were no emails. Humans were not able to communicate with each other. Now with this
Uh,
digital age,
So, Dr. Devashish Das, sir, pardon,
yes, sir.
if you can put the presentation in the presentation mode. So I
Okay,
think.
sir.
I think F5, if I press F5, or you can just press that button below, just beside, if you go below, there's a cup sign out there. It looks like a cup sign. Absolutely on the right side. Can you see
Yes, sir.
this? No, on the left hand side, bit left. There's a cup sign out there. Yeah, now just a little bit to the right. Yeah, a little bit to the right. The last icon.
Yes,
No,
sir.
yeah, this one, yeah. So we will be now, I think this will go into the, yeah, thank you, sir.
Yeah. Yeah. So, why this concept of cloud came? I was talking about this internet communication. Now, in 1970s, when the local area network was discovered by the army of US during the World War. So after that, slowly this concept of distributed systems came, right? So now gradually what we are doing, we are moving from internet of humans to internet of things. That means the things are communicating with each other, the machines are communicating with each other, right? Now in the manufacturing industry, if you have seen, all of them has become automated. It has become smart manufacturing. So that is one of the applications of Internet of Things. Now, in Internet of Things, to provide better quality of service to the customers, so the customers they slowly move from grid to cloud and then to fog. Right now, every this cloud concept, it is a very beautiful concept because every organization has their own cloud. For example, if you are using Gmail, you could have seen Google has given a ample amount of space to store your mails that are important mails as a backup. So that is also a form of cloud. Now everything has become online, right? Whatever program you want to wish, you don't want to install the software. Just go online, program it, save it in the server. That is also an application of cloud. Right. Now to add, now to reduce the burden on the cloud servers, the concept of fog computing was proposed. So if you see the diagram, so this is the concept of cloud, right? And these are the edge devices. Now, if you go to the fog computing, the fog layer is in between the cloud and the edge devices. So to reduce the load on the cloud servers, a new concept was introduced, that is the fog computing. Right. Basically, these end devices, these are nothing but the devices that communicate with each other, and this is known as Internet of Things. So, Internet of Things, they do not directly interact with the cloud data centers. Rather, these applications will be forwarded to the fog nodes. The fog nodes will process it, then it will be forwarded to the cloud data centers, thereby minimizing it. So this is the concept of cloud and fog computing. Right. So on August 9th, 2006, the CEO of Google proposed the concept of cloud computing. And in 2012, Cisco proposed the concept of fog computing to normalize the loads on the cloud servers. So both are the form of the distributed computing. Now, what is QoS? Quality of service. Now, I'm giving an example. Suppose I need my memory space is 4 GB and I need a software that is 16 GB that occupies 16 GB. So what I will do, I will request each of the participants, you please give your laptop. Will you give me? Will not give me. What I will do, I will logically borrow the CPU cycle or the memory from your system, right? So that I can run my program. I can run the software. That is the advantage. Right. So one punch line of cloud goes like this: pay as you go. So how much hour I will reach, that much for that much hour I have to pay the amount. Right. So who are you? You are nothing but the broker. Right. The broker is a middleware that stands in between the user and the cloud resource. Now coming to QoS, right? Quality of service. So what is quality of service? The types of service which you expect from the servers, from the resources, right? The quality of that service, that is called as quality of service. So if you define it, then it goes like this: the level of performance which is experienced by the client upon invoking an operation by a remote server. So quality is a non-functional characteristic such as reliability, load balancing, resource allocation, security, task scheduling, and so on. Okay, then coming to the how to achieve this quality of service parameters, what are the ways? Now, for example, in order to make the cloud resources reliable, because we don't know that suppose if I am borrowing your system, how much reliable is your system? Is it secure? Have you installed any antivirus? If not, then my data is gone. Everything is lost. Right? How to ensure that? So we have to give some security policy. Right? We have to enter into an agreement. Right? That agreement is called a service level agreement between the user and the broker who is providing the resources on the cloud and as well as the fog. Right? Now, how to do that? If you if I will give you more money, then you will give me more memory. Your system will be highly reliable. Right? High-end antivirus will be installed on your system. Right? Now, suppose I will give you $10,000. You can purchase a supercomputer and give it to me. That is more reliable because the computation is faster. So as the cost grows, the reliability will also grow. The security features will also grow. Right? The loads will be balanced. Everything will be balanced. But that is not our target. What is our target? Our target is to achieve these objectives with less cost, minimum cost. Right? That is where optimization comes into picture. So what is optimization? Optimization means reducing to some extent. We are not completely eliminating it, but we are reducing it to some extent. That is called optimization. So optimizing a thing, right? Getting less time and less cost. If there is a processor with less time and less cost, then we will be able to allocate a job to that processor and get it done. Right? If I am getting a laptop with 30,000 or 40,000, why I will spend 1 lakh rupees for an Apple system or a MacBook? My work will be done. Everything is online now. Is not it? So that is an example of optimization. Now, how optimization can be done using the soft computing techniques and recent advancement in optimization that goes with the machine learning techniques. So I hope all of you must be acquainted what is machine learning and what are the various types of techniques. Right? So machine learning is the ability of a machine to learn by itself through experience without being programmed. That is called machine learning. Right? So everyone is now talking about artificial intelligence, Internet of Things, but how this Internet of Things exists, how this artificial intelligence exists, only due to this machine learning technique. So machine learning technique is a subset of artificial intelligence mechanism. So machine learning techniques can be broadly classified into two categories. First is supervised, second is unsupervised. Now, what are these things? Supervised and unsupervised. Right. For example, when you are showing a fruit to a kid, right? Your younger brother will be there, or your child will be there, and you are teaching them A for apple, B for ball. How you teach them? You show the objects. This is the apple. This is red in color. This ball is round. So you teach them, and then what you do? You conduct some tests. You conduct some exams. You show a bunch of fruits, and you ask your to identify which is an apple. Easily you can identify. That is called as supervised learning. Right. So we have some artificially generated algorithms that are called supervised algorithms that make the machines learn. Right. With the presence of a supervisor. Then coming to the unsupervised learning. In unsupervised learning, there is no supervisor. The machine will learn by itself. Right. So there are two phases for a machine to learn. One is the training phase, one is the testing phase. Right. So I assume many of the faculties will be here. So when you are taking classes, right, you train the students, right? You are handling a particular subject, you are training the students with the theory and practical. Later on, you test the accuracy of the students, how much the students have learned. Is your teaching effective or not? That is called supervised learning. But if the students learn by itself, there is no exam. Right? If you want, you can take the exam, but the students will learn by itself. That is called unsupervised learning. Nowadays, students are learning from YouTube, Coursera, EDX, many sites are there. So students learn by itself. That is called unsupervised learning. Right? Without the presence of any supervisor. So examples of supervised learning, you must have heard about this classification of the objects. Right? Classification of human beings based on genders, male and female. Right? So if you show an image, we the humans can easily identify whether he is a boy or a girl, a man or a woman. Or if you show the photo of a fruit, then we can easily identify which fruit it is by looking at it, because we have learned that. But how the machine actually classifies it, how the machine will learn it. So we have to feed some of the fruits of the pictures or the images of some fruits continuously to the machine. That is called training phase. After that, you show a particular fruit and the machine will show the output that this is apple or this is orange or this is grape. That is classification. Okay. Next type of supervised learning is regression. Regression means, suppose you are buying a house, right? While purchasing the house, what are the factors you look? What is the cost of the house? Right? Is the house as per your requirement? What is the distance from your office to the house? What is the distance of the kids' school from your house? What is the distance of the nearby market? Everything you see, right? Then you arrive at a decision. That same decision, if you leave to a machine, right? The machine will predict the price for you. These are the parameters to tell me what is the price of the house. The machine will tell you. That is called regression. Next is artificial neural network. So this is a hot area and very interesting area. Artificial neural networks. What is artificial neural networks? You must have heard about Stephen Hawking, right? Stephen Hawking. He was a mathematician, but he is actually the father of computer science. He actually built the first computer. Now, what scientists are doing, they thought that why the systems or the computers cannot think like humans, why they cannot take their own decision. They can take. So what they are trying? They are trying to embed the human brain within the brain of the computer. Right? Artificial brain. They are trying to put the artificial brain. Right? And those artificial brain, it will work similarly to our human brain. So that is the basic foundation for artificial neural networks. Then comes unsupervised learning. Unsupervised learning, again there is no supervisor, the machine will learn by itself. So one is clustering. What is clustering? Clustering means grouping the similar type of objects. Okay, grouping the similar kinds of objects. Suppose there are 10 fruits. The fruits that are orange in color, that will be in one group. The fruits that are green in color, that will be one group. The fruits that are red in color, that will be another group. So each group is called as a cluster. So that clustering happens, that is conducted by the machine itself without the help of a supervisor. That is called as unsupervised learning. Right. Another type of machine learning technique is fuzzy learning. Fuzzy learning. After some time, I'll show you my research work and some of the papers where you can see how the fuzzy logic is applied, how these optimization techniques are applied, right? How can we apply the regression and ANNs to optimize our quality of service parameters. Okay. So coming to our research topic, a cloud as well as fog networks need to be cost effective and highly reliable. As I said, so with low cost, we can achieve higher reliability, right? Or with less time, how a processor, right? A processor that takes less time and it is more faster, automatically it will be costly, right? But due to this cheap design, the systems have now become cost effective. Right. Now, what is the target? The target is the cloud network, the cloud where you are giving your inputs, where you are giving your data, that should be highly reliable, highly secure, and cost effective. Right. So it must have the ability to transfer maximum amount of data for end-to-end delivery. So that means you need higher bandwidth. But again, higher bandwidth means higher cost. The question is how to reduce the cost. So that becomes a constant for us. So many researchers conclude with a binary state of operation. Binary state of operation means for every resource, there are two states. One is the active state, one is the failed state. So active state means 1, failed state means 0. Right? Although some research reveals that grids, clouds, fogs operate with multiple state of connections and operations, but they are silent about the mentioned constants. What are the constants? The biggest constant is cost. Right, the biggest constant is cost. So, since there are multi-state operations, multi-state means, for example, if you have a network, right? If you have a graph, the nodes that represent the processors, and the link that shows the connectivity between the nodes from the source to the destination, maybe in the grid network or in a cloud network or in a fog network. Now, every link, right? Every link has multiple load states. So depending on the loads, the reliability will also vary, right? For example, suppose you are in Kolkata. From Kolkata to Bhubaneswar, right? From Kolkata to Bhubaneswar, there is a single national highway, right? You have constructed the national highway. You are part of that. Now, if you run a bicycle, what is the reliability? The reliability will be higher. The road will last longer. You travel by two-wheeler, you go by four-wheeler, then also the reliability will be balanced. But if you go by 16-wheeler trucks, containers, big containers, right, with steel wheels, then automatically the reliability will decrease. Yes. And how many vehicles per minute or power or per hour that passes through that road? That is called the bandwidth. So what is the amount of load you are putting on the link on the road? That is also a constant. And obviously the cost. So the reliability depends on the load, bandwidth, and cost. So this was my first paper. Just a minute, I will show you my papers. Yeah. System reliability estimation of constant multi-state computational bits. So here what we have done is, straight I will come to the problem statement. So compute the system reliability. This is total bandwidth by total cost plus the load of the minimal path. So minimal path means we have mapped it as a network. Yeah, this one. Right. So these are the links, and this 1, 2, 3, 4. These are nothing but the processors in the grid network, or you can say it as a cloud network.
Dr. Das,
Right. Yes, sir.
I'm not able to see the. Are you? I think we are on a slide. I think is that the slide or you're showing something? Some other
No,
slide?
sir. This is the PDF, sir. PDF.
PDF. No. We are not able to view the PDF. I think we are still on the PPT. because
Okay,
I think
okay,
the
sir.
screen has
Just
not
a minute.
refreshed. If you could
Okay,
just
sir. Just
I
a
don't know.
minute, sir. Just a minute. Yeah, now it is visible, sir.
Yeah, it is now visible. Thanks. Thank you.
Okay, yeah, yeah. So here goes the objective function. This one, total bandwidth by total cost, plus this is the maximum load on a link, and this is the minimum load of the link, and this should be less than the total bandwidth. So as it is a distributed system, so we are focusing on the bandwidth and the cost, because these are the two major constants, right? So these 1, 2, 3, 4, these are numbered, and these are nothing but the resources or processors, whatever you can say. That is a form of the that is a part of the fog network or cloud network or grid network. So what we have done is our algorithm goes like this. We have found all the possible minimal paths in this network. Okay, so in this network, all the possible minimal paths are found, and then what we have taken? We have taken the C for edge E1. These are the loads. So if you take these are the loads, so normally what we will do, if the load is less, then the reliability will also be higher, right? The reliability will be higher. And how we have found the reliability? By using the exclusion inclusion principle that we are using in probability. Why? Because the system reliability is nothing but the possibility or the probability of a node that is working for a certain period of time, right, under some constraints. So this is the algorithm. So first we have to do, and what is system reliability? System reliability means given the reliability of each of the links, right, given the reliability of each of the links, what we are doing, we are estimating or evaluating the reliability of the entire system or the entire network. So this one, if you are mapping to a cloud or a fog network, right? So reliability of each link will be given as well as the bandwidth will be given. And what you are going to do, you are going to evaluate the reliability of the entire network. So if you take it as a small network, this algorithm can be recursively applied to all the small networks, and then you can aggregate it to a bigger network. Okay, so what is the input here? The input is the cost matrix, bandwidth matrix, reliability matrix, and load matrix. Right? Why matrix? Because we are taking it as an adjacency matrix for this network. Okay, and then what we are doing in the step number 1, we are finding the disjoint minimal paths. Then we are finding the minimum assigned load of each minimal path, and this is the objective function. Next, in this paper, this is the second paper. In this paper, what we have done, that proposed formula for evaluating the reliability that needs to be optimized. So how we are optimizing? We have optimized using the genetic algorithm. So as I said, these are the two constants, major constants, cost and bandwidth. So our objective is twofold. It is a multi-objective function. So what is twofold? So with less cost, we can get higher bandwidth so that the data can be delivered from the source to the destination as soon as possible, and quickly it will get processed, right? And simultaneously we have to achieve higher reliability. Okay, so this is the objective function, maximum Rij by Cij. I means I is a node and J is a node, and Cij means this is the cost. Rij is the reliability, right? So if you say Rij into 1 by Cij, that means it is inversely proportional. Then Xij is a decision variable, either it will be 0 or 1. So together it is called as the utility function or the objective function, right? And what are the constants? The constant is this cost of each link should be less than or equal to the total cost of the system. Similarly for the bandwidth. And what is Xij? Xij is a variable. So if there is a link between the nodes I and j, it will be 1, otherwise it will be 0. So what we have done is, in genetic algorithm, I hope all of you must be acquainted with genetic algorithm processes. So there are a few things in genetic algorithm. The first process is generating the initial population, right? So this is a grid network. This is a grid, a small grid network, or you can consider it as a cloud network, right? And what is the initial set of population? Population is the initial set of solutions, right? With the disjoint minimal paths. So what are these? These are nothing but the minimum spanning trees, right? So minimum spanning trees will be taken as a set of solutions. Then what we are doing? We are doing the crossover operation. This is the example of crossover operation. Right, these are the two parent networks, means two MSTs taken from the solution, and these are the two childs. So you see, wherever there is a link, right, in the crossover there will be some alternate links. Okay, this is the crossover operation. Then comes the mutation operation. So in case of mutation operation, what happens? We have suggested an algorithm that if you consider this as a network, then what is the degree of each node? Right, the degree may not be uniform. Somewhere it will be 1, somewhere it will be 2, somewhere it will be 3 or 4. So to balance the degree of each node, to make it a regular graph, we are going for the regularity check and effect. So you can see the node numbers and these are the degrees. Right, then we have to balance the degree of each node so as to make it a planar graph. Right, so this is the algorithm. Select any two candidate networks from the population pool using the selection algorithm. So selection algorithm, we have used this Rowlett wheel selection. Then apply the crossover to the selected networks to get two child networks. Crossover operation. Then the mutation algorithm is nothing but this regularity repair. Regularity repair means we are taking the means making it uniform, the degree of all the nodes. Then calculate the reliability of each child. How the reliability is calculated? Using the inclusion and exclusion principle that I had shown in my previous paper. Right. So those childs that are better than the parent are promoted to the next generation, means next iteration. Repeat the steps 2 to 5 for each possible pair of parents from the population. Now, what is the stopping criteria or the elimination criteria? The elimination criteria is those parents that does not satisfy the constraints that is levied on the objective function, right, or that does not satisfy this crossover or mutation criteria, they are automatically eliminated. And how it will stop? Once the population get exhausted, once the solution get exhausted, then it will be automatically stopped. So these are some of the input networks, the sample networks, which you have considered for our experiment. Okay. So these are some of the sample networks on which it is implemented. These are the input networks. Yeah. These are the input networks and these are the optimized networks. So in optimized networks, what we are doing? We are just keeping the nodes constant, but we are reducing the number of links. So with that, what will happen? The reliability will increase and the cost will get reduced. This is the work that we have done. And this is the mutation algorithm, which we have named it as regularity repair. So the number of generations that we have taken is 200. That is the number of iterations. The population size is 111. So 111 number of MSTs or graphs are generated. Okay. Then what is the population? Population, we have taken 20 randomly generated spanning trees out of the population. So out of the total population size, this is the initial population. You can take it any number according to your convenience. Then population selection or the selection process, we have considered the Rowlett wheel algorithm. Right. Then the crossover rate is 0.85. These are the threshold values. Then the mutation rate is 0.20. And what is the stopping condition? The average system reliability of the present generation is equal to the previous generation. This is the stopping criteria. right? And these are the values you can see. The input, for example, with a network with 10 nodes and 80 number of links, the input cost is 250. The input bandwidth is 3 Mbps. The input reliability is 0.8149. Population size is 250. In the output network, the optimized reliability is 0.922, and CPU time means for executing this, the total time is 2.9. Now you see, if you are increasing the number of nodes to 12 and the number of links is still 18, the input cost will be increased 30. That is, it becomes 280 with the increased bandwidth. So bandwidth will also rise from 3 Mbps to 5 Mbps. Okay, and these are the graphs that will plotted. So comparison of optimized reliability and input reliability versus cost. This is the input reliability and this is the optimized reliability. So you see, in the input reliability, with the increase in cost, there are chances that the reliability may decrease. If you increase the number of links or the number of nodes, the reliability may somewhat decrease. But in our case, if the cost increases, the reliability will increase, or if the cost decreases, then also the reliability will increase because we are optimizing it. Okay, and the next graph is CPU time versus the population size. Population size means the set of solution. How many graphs are there? And this is the time for execution. As the size of the population will grow, I mean the solution set will grow, more time will be required for execution. Right? So the CPU time will grow. Next one, number of nodes versus average computation time. How much time is required for computation? This is the average time, and this is the number of nodes. If we increase the number of nodes, right? This is our proposed approach. This circle set, right? See how it is minimum, and this is the approach that is suggested by one of the persons in 2012 in his paper. So see how the computation time is increasing. But our approach, it is minimal. So this is what is actually optimization. Okay. Then comparison of system reliability versus population size. Then the set of solutions, then the system reliability. You see, the system reliability is almost uniform in our approach. So no doubt the solution space is large, it will increase, but still then the reliability of the entire network, that is called system reliability, will be almost uniform. But in the approach that is suggested in 2012, you see fluctuation is there. Then there are other graphs like crossover rate versus system reliability, context mutation versus system reliability. So this is the work that was accepted in the Journal of King's of the University, Computer and Information Sciences in 2018. This is my second paper of my research work. And for you guys, there is a paper, I'll show it to you. For computing, a taxonomy, survey, and future directions. So it is written by Redovan Mohammed, Ramohan Kotagiri, and Rajkumar Buyar. Right. So you can refer to this paper for the survey and future directions, future research directions of fog computing. What are the challenges? Challenges, if you see here, it is mentioned about reliability. Okay. So these are the taxonomies. These are the objectives, service level objectives. What are the services that the user expects from the fog network? Right, cost management, network management, then bandwidth, right, latency. So everything is there. You can follow this paper. It's a very good paper. What are the applications? Okay, then these are the security features. So fog computing is an emerging area. If you are interested, you can work in this. Very less work has been done. So you can target reliability optimization, or you can go for load balancing, you can go for task scheduling, or even if you focus on the security, it will also be a good work. Okay, so see, sustainable and reliable fog computing. The overall sustainable architecture of fog computing is subject to many issues like assurance of QoS, service reliability, energy efficient resource management, etc. On the other hand, reliability in fog computing can be discussed in terms of consistency of fog nodes, availability of high performance services, secure interactions, fault tolerance. In the existing literature, a very narrow discussion towards sustainable and reliable fog computing has been provided. Further research in this area is highly recommended for the desired performance of fog computing. So this is what I want to address. Okay, so one of the questions is that what is the difference between internet, cloud, and fog? Internet is a vital component of cloud and fog. See, cloud and fog both are different in the sense that means both are similar in the way that they are a form of distributed computing, but fog network or a fog layer is an intermediate between the edge devices or the IoT devices and the cloud network. The actual processing was done in the cloud network, but due to overloading of the cloud servers on the cloud data center, people slowly migrated or withdraw some of the basic services of the cloud and they moved to fog layer. Right, a very good example, simple example I am giving you. In your day-to-day life, right, during the winter season, you see fog. So cloud is on the sky, right? You are on the ground. So in between you and the cloud, there comes fog. You wake up in early morning, you see fog everywhere. So in that case, the fog will appear as an intermediate layer between you and the cloud layers. It is just a backup for the cloud to enhance the services. That's it. So I have different papers. We can also see here. And then I will show you one more machine learning method for reliable resource provisioning in edge cloud computing. This also you can see. Okay. This paper also you can refer. Machine learning method for reliable resource provisioning. Here you can see all the businesses. You see, this is actually the cloud layer, right? Cloud network. These are the end devices, and intermediate. This is the fog layer. So in your cellular network, your base station works in the fog layer.
Dr. Das,
Yes, sir.
Naveed, I have a small query. Like, if you know, in the last almost 5 years, Government of India, through its smart city mission initiative,
Yes,
had deployed across more than 100+ cities, multiple of smart devices across the different cities. Some on a greenfield approach, maybe some in normal whatever the cities there. Now, in most of the city deployments, from my perspective, I'm basically quite attached with a lot of smart cities deployment in such deployment, which we have noticed that in multiple places cities have deployed environmental sensors.
Okay.
To capture different type of data with respect to different air quality index, rainfall, wind speed, light ambience, and all. So all these sensors have a an application which is actually operating on a SaaS model from a cloud environment.
Exactly.
Now, through these sensors have SIM devices. These are GSM-based SIM devices.
Okay.
And they, through the mobile network, it interacts with the cloud. So what we see is of late we are seeing there was a lot of queries coming in that there's a lot of latency which was observed in the fetching of data. Like if the refresh interval we were keeping say around every 15 minutes, maybe it was okay, but as we decrease the refresh interval, what it was observed, there was a latency. So in this kind of a scenario, from a smart city infrastructure, say suppose a city has its own captive data center, and if that application can be brought from the cloud and deployed on a local base, that means on-prem, and it is connected directly through a dark fiber medium.
Okay.
So will that improve the performance, or you need something else? I mean, how can you suggest? I mean, since you have already done so much work on this, so what kind of inputs you can give us? I mean, in this regard. So we just wanted to your thoughts on this.
Yeah, sir. As per my knowledge, some of the part of this work can be diverted from the cloud to the fog layer, so that everything we don't depend on the cloud network. We can operate on the fog network and the edge network, sir. And then the load will be balanced on the cloud data centers. So every time we don't have to depend on the data centers of the cloud services. That is my view.
Okay. Now you talked about this algorithm. Now, I mean, this is very obviously software-defined network has been there for quite long. I think it's almost 10 years now.
Yeah.
And Cisco as a OEM has been working a lot of different type of protocols and algorithms. And I believe similar on this kind, there was an algorithm, proprietary algorithm which Cisco had, which is EIGRP, which had operated on 5 different metrics. That was bandwidth, delay, load, reliability, and MPU. So based on that is to calculate the shortest path to where it can not compromising on the quality of services and the performance based on whatever bandwidth you had. So this particular whatever you have just now explained, the fog network, how far it is related with this? I mean, is there a very what is the differentiation between this? Is it very much in same lines or different?
Exactly, sir. Same line, sir. Same line. But the thing is that, sir, if you provide higher reliability or higher bandwidth or more security, then obviously you will charge more from the customers. That is what we are doing. But my work, we have the target that with minimum cost, how can you achieve higher bandwidth and higher reliability and more better services? That is why you are going for optimization.
Yeah, and what sort of security like we are looking at that for this year? Like you spoke about encryption. So the moment you have encryption, automatically it brings around it brings about latency also. So with encryption, more latency comes into the system. So how this can be addressed? So if the level increases, day to day networks are being compromised, so the encryption level is getting much more stronger. And so in this kind of environment, if tomorrow, if I say if the metric for encryption, we need more higher encryption or more higher security features to be added, how this will impact this network in this way?
Exactly,
how this will impact?
Yes. So nowadays, as per the industry concerns, people are migrating to digital certificates. So digital certificates is cost effective and it is a better security measure. So whenever you are accessing a cloud platform online, they're first asking you for a hash key. So that hash key will act as a security measure here.
Right. For the audience, I mean, if anybody has any questions, you can put it on the QA board. I think we are not seeing many questions coming out, or if someone wants to speak, maybe you can just put in, we can just ask you to speak. So Dr. Das, I mean, you have
Yes, sir.
anything more to present us, the presentation part?
No,
Or
sir. No, sir. It's over, sir.
not? Okay. So the floor is now open to questions. I think we have covered quite a lot. And any questions and queries from the participants out here? Please, questions are welcome. I think this is a very informative session. Of course, I have learned a lot also. I'm not saying that. It will be very informative for me because I'm working very much close with Smart City Mission for one of the states, one of the cities, and we are doing quite well. So I'm trying to, understand how will I will try to implement the same thing. While when I go back, I'll try to take some ideas, and maybe if required, I'll interact with you also, if
Yes, sir,
required, if
definitely.
needed, and to see
Definitely, sir.
how we can get it done. So
Yeah.
please, if you have any queries, please post, and if I ask, please.
Sir, this is also a paper. I wish I could show this one at
Yeah,
the
please,
same
please,
time.
please,
This
please.
one, sir. This one. The load balancing and optimization with machine learning in the real-time fog computing environment. Yeah, the load balancing and optimization strategy using reinforcement learning in fog computing environment. It is a real-time implementation, and this paper has been published in this November 2020. It is a recent work. So real-time fog computing environment using fuzzy and probabilistic neural networks. Because nowadays people are migrating to this. Yeah, how can we put fog technology in DC and DRC? Yeah, Subrat sir, what is this DC and DRC? Are you talking about DC motors? Yeah, Mr. Subrat.
And data center, I think DC. How can we put fog technology DC and DRC? So data recovery cloud. So data recovery in cloud
Recovery center.
Yeah, recovery. Yeah. So
Data
I think
center.
that's the question. Right,
Yes,
Mr. Subrato, I think that's your question, sir. I believe maybe if I don't think so. He is.
Yes, sir. It's a very good question. Research is going on this, so you can have the data centers in the cloud environment. Those data centers doesn't interact directly with the IoT devices because it has become dynamic. It is no more static. So what the end devices are doing, they're interacting with the fog layer, and through the fog layer, some of the data are moving to the data centers. You are not directly interacting with the data centers in the cloud environment. We have a feel that we are interacting with the data centers directly, but that is not the case. Suppose you are designing a IoT device, a IoT circuit, the data will not flow directly to the cloud. The data is not getting stored to the cloud. Rather, we can implement a fog layer in between the cloud data center and your devices. That is the thing. I hope I am clear about this question.
I think, Mr. Subrato, I think, have we able to answer your queries? I mean, so if not, you may, okay, let's see. I think he has posted. Okay, so he's quite comfortable with the answer. Good. Any more questions? I mean, we have a lot of time. I think we have another 17 minutes to go. So it's just 17:13, 7:13. So we have.
So yeah, this is also a good paper. You can see effective load balancing for real-time fog computing environment using fuzzy and probabilistic neural networks. So neural networks also can be used for optimization of these things. So you see here, these are the end users, these are the IoT devices. This is the fog layer, and this is the cloud data center. So Mr. Subrat, whatever you have asked, this is the answer to your query. So we understand that the end devices, they have become dynamic in nature, right? These are the IoT devices. Suppose you are building a circuit and we think that the data is interacting with, the data is stored directly in the data center in the cloud, but no, it is passing through the fog layer. See here. So some of the data centers are also.
Could you, Dr. Das, could you explain
Yes,
this
sir.
architecture? I mean, this architecture what you just opened right now on the screen.
Sir, this one.
Yeah.
Yeah. Sure.
Yeah, please.
So these are the devices. These are the healthcare devices. Because this paper is highlighting the healthcare system, but you can use it in any of the applications. Now here what happens, there is a new layer called the dew layer. Dew means the dewdrops. So this layer can also be eliminated, and some of the data centers from the cloud, they are moving to this fog layer. This is actually a backup. This is not the real data center. This is only the backup server. So the data from these devices, from these healthcare devices, they are fed into the data center and get stored in the fog layer. But what we are doing, we are assuming that all the data gets stored in the cloud. No, this is getting stored in the data center in the fog network. Rather, the fog network will send a request to the cloud data center if any data is required, and then it will give a reply and a feedback system. So instead of the end devices, the fog devices will interact with the cloud data centers. It is not the end device. That is the thing. Okay. So FS is the fog server. Then FMS is the fog master server. Master server means these are the data servers. So whenever you are interacting with this fog layer is actually transparent. It is not visible. So whenever we think that we are directly interacting with the cloud server, but no, that is not the case. Okay. So
Yeah, very informative.
Yes, sir.
Good. Any other questions from the audience? I think I think people can ask a lot of questions. I think we have a lot of participants, around 45 odd participants we have today. More questions are welcome.
Will disaster recovery center get the effect of fog immediately as we see? Yes. Because there is a network coming up. If you have heard about this DTN? Yes. DTN networks. In this DTN network, this will come into picture. In the DTN networks where it is effective. Suppose in a fraud affected area, right, where the network is not there, even if you are not able to set up the ad hoc network, right, some people are injured, some people are affected, you need to provide the medicines and other healthcare facilities or fooding or water to those people. How do they communicate? They will communicate only with the help of DTN network. And in DTN network, you can also provide your own, you can set up your own cloud data center. You can also set up your fog center. Right, but basically you have to go in a hybrid mode, the combination of this wire and wireless. Okay, any other query? Any other query? Virtual private network, yes. No, it is not VPN, it is DTN. It is DTN. DTN. Okay, DTN. You search in the internet, you can find it. What is DTN? I hope I have cleared your doubt. Over to Iqbal sir. Iqbal sir.
Yes, yes, Dr. Das. I
Yes,
think
sir,
Do we have any other questions posted? I believe no. Okay. So I believe today's session which we had was indeed very much informative, and we really learned a lot. I think everybody will all agree that today this particular topic, reliability optimization in the cloud and fog environment using machine learning techniques, was very informative. Small request to Dr. Debashis Das. If whatever the presentation you have right here, if that can be shared with Institute of Engineers for the benefit of other members, it would be great if this can be shared with all the member audience.
I'll share it.
So, yes. So with this, I would like to call upon Dr. Raju Boshak, Honorary Secretary, West Bengal State Center, to give a vote of thanks. Dr. Okay, I think Dr. Raju Boshak is not yet. I think he's busy with some other work and he's not there. So I've been requested by the chairman that I propose a vote of thanks. Thank you. So it's indeed a proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in the technical webinar on the theme reliability optimization in cloud and fog environments using machine learning techniques, which was organized by Computer Engineering Division of West Bengal State Center through this online platform, Zoom platform. On the outset, I convey my sincere thanks to the panelists, Dr. Debashis Das, Assistant Professor, Senior Grade 1, School of Computer Science and Engineering, VIT Vellore. My sincere thanks goes to Dr. Nirmal Das, Chairman, West Bengal State Center, Dr. H.O. Thackeray, President, Institute of Engineers, West Bengal, for India, sorry. Mr. Sandeep Kumar Deb, Vice President, Institute of Engineers, Mr. Amit Kumar Das, Chairman, Computer Engineering Division Board, Institute of Engineers, Dr. Ranganath, Dr. G. Ranganath, Chairman, CATE, Institute of Engineers, Dr. Shravan Sarkar, Deputy Director General and State Informatics Officer, National Informatics Center, West Bengal, and Chairman, Computer Division, Engineering Division of Subcommittee, West Bengal State Center. The same feeling, is also being showered to all the members of the council and the division board members of CPDB, all members of the committee, West Bengal State Center, and all members of the Computer Engineering Division subcommittees, Director Technical, Institution of Engineers India, and his team for their wholehearted support to make this program a success. Last but not the least, my sincere thanks also goes to all who are behind the screen and giving their silent support in this technical webinar. Thank you. I think with this, we come to the end of this webinar.
Sir, can I get your mail ID so that I can share my papers and the PowerPoint presentations? The paper
I believe I think mail ID is with Mr. Pranab, Mr. Pranab Kumar Deb. So I'll try to see if I can share it. What I'll do is I can put it here on the board if possible.
Yes, sir. You can put it.
Let me see, because I need to see where I can put my mail ID out here. I am not finding any place where I can put my email ID, because being a moderator also, I don't know where I have an option of putting any.
Yeah. Or otherwise, you can give the official mail ID. I mean, the mail ID of Institute of Engineers.
Yeah, I think that is with Mr. Pranab Kumar, the person who's there. So Pranab,
Okay,
could you just share the mail ID with Dr. Debashis Das, so he can share the presentation with all of us. So thank you all once again for a wonderful Dr. Debashis Das and everyone, all the participants.
Thank you, sir. Thank you.
Thank you. Thank you.
So with the permission of the chair, I am ending the webinar here, sir.